So let's look at some examples that have variables in them. So multiplying the fraction 2x plus 4 over x plus 1 times the fraction x squared plus 3x plus 2 over 4x plus 2. When we multiply fractions, recall that we're going to multiply straight across. We're going to multiply this direction. So numerators get multiplied, denominators get multiplied. But as we mentioned in the last examples, it's going to be much easier if we can cancel things first before we complete the multiplication across. To do that, we have to have things factored. So we're going to factor the numerators and the denominators of both fractions before we try to multiply straight across. We're going to factor them to see if we can find something common that can be canceled. So in my first numerator, 2x plus 4, there's a 2 in common. If I take it out, I get x plus 2. The denominator has nothing common, and it's not a square, so the x plus 1 is in factored form. I'm going to put parentheses there just to emphasize that I tried to factor and it doesn't. The second fraction, the numerator, is a trinomial, so I'll go to a binomial times a binomial. X squared factors to x and x. To factor 2 to get 3, I want to use plus 1 and plus 2. Don't forget to always check your factorization by multiplying it out before you continue on. In my last fraction, denominator, I have 4x plus 2, which has a 2 in common. So I'm going to get 2x plus 1 as what's left over in the parentheses when I do that. So when we look at what's left here, we've got 2 numerators and 2 denominators. I can cancel common factors from the numerator to the denominator. I cannot cancel common factors that are in the same location. So this x plus 2 and the x plus 2 that are both in the numerators, those cannot be canceled because they're both in the numerator. So it has to be numerator to denominator. So this x plus 1 in the numerator will cancel with this x plus 1 in the denominator. The other factor that's common is the 2 here. There's a 2 in this numerator and a 2 in this denominator. When we look at everything else, there's nothing in the numerator that will cancel that is exactly the same as what's in the denominator, so there's nothing else that will cancel. So at this point, we multiply straight across. The x plus 2 multiplies to the x plus 2 that's also in the numerator for the second fraction, all over 2x plus 1. This would be our final result. We generally don't multiply that out, we leave it in factored form. In fact, the other way you could write this answer out is to say x plus 2 quantity squared, because there's 2 of them, all over 2x plus 1. The other thing to do before we go on is that, remember, you can only technically cancel something if the thing you've canceled, as long as it wasn't 0. So 2 was not 0, but here we had a cancellation of x plus 1, which we're saying cannot be equal to 0. So that means x cannot be equal to -1. So it's always a good idea at the end to actually clarify that this simplification is only correct as long as x is not equal to -1, whichever way you write the result down. So there's an example of multiplying where your rational expressions have variables in them. Another example. Here we have a squared minus 1. We want to factor that in the first numerator. That's a difference of squares, so a plus 1 times a minus 1. And then my denominator, 5a minus 2, has nothing common. So we'll just write 5a minus 2 and we'll put parentheses around it. It can't be factored further, so we'll just kind of show that with the parentheses. My second fraction, 6 minus 15a, notice how it's not written in descending order. So the first step is to write it in descending order. So negative 15a plus 6. And because it starts with a negative, on our next line we'll factor that negative out with whatever else is possible to factor. My second denominator is a trinomial, which can be factored into the product of two binomials, specifically a and a. And the minus 6 will factor with a positive and a negative. Specifically, if I want to have a positive 5 in the middle, I want to use a positive 6 and a minus 1. All right, we still have a numerator here to factor. We want to factor a negative out of that second numerator. I'm just going to rewrite everything else down in the meantime because everything else is factored. So we have this numerator left to factor the second numerator, negative 15a plus 3. There's definitely a negative that I want to factor, but there's also a common 3. You should always take as much out as you can. When I take that negative 3 out, negative 15a divided by negative 3 is 5a, and positive 6 divided by negative 3 is minus 2. Once I have everything factored, then we try to cancel common factors from numerator to denominator. So in this numerator, I have an a minus 1 and an a minus 1 here. And then I have 5a minus 2 and 5a minus 2 here. So I'm able to cancel 2 common factors. And what's left we'll write together. Negative 3 going straight across times a plus 1. It's tradition to write a coefficient out front first. And then in the denominator, I have a plus 6. So that would be your final simplified result. We generally don't multiply the negative 3, although you wouldn't be marked wrong if you did. The last thing is to recognize that these things you canceled in the step before, technically it only works as long as they're not equal to 0. So a minus 1 is not equal to 0 as long as a is not equal to 1. And then 5a minus 2 is not equal to 0 as long as a is not equal to 2/5. So there's actually two values here that a cannot be. These are the restrictions that must go into play for this to be a simplified result. So there we have it, 2 examples of multiplying rational expressions. Remember, always simplify by factoring and canceling common factors before you multiply straight across. Here are 2 more examples of multiplying with rational expressions. If you want to, you could pause the video and try them out and then unpause and see if you got the right results. I'll go ahead and work through these. First step, when you're multiplying rational expressions, factor. So we're going to factor the numerator and denominator in both of these initial fractions. W squared minus 9w has a common w in it. Factor that out and we'll get w minus 9 left in the parentheses. My denominator is w squared minus 9. That is a difference of squares. So we're going to have w plus 3 times w minus 3. Now that numerator and denominator looked awfully similar. Remember, your first step is always to look for something common, which is why you hopefully recognize that ends up not being a difference of squares, because when the w comes out, the w that's left inside is no longer a square. In the second fraction, w squared minus 3w, once again we have a w that's common in both terms. Factor it out and we get w minus 3. In the denominator we have a trinomial, which will factor into the product of 2 binomials. W squared goes to w and w. Negative 18, we will want to factor into 1 positive, 1 negative. Specifically, if we use positive 9 and negative 2, we'll get a positive 7. I want a negative 7, so I'm going to use the 9 as a negative and the 2 as a positive. That will give me a negative 18 when I multiply it, but add up to a negative 7. Now we've got the numerators and denominators all factored. So what we're going to do is cancel common factors from the numerator to the denominator. So w minus 9 here in the numerator cancels with this w minus 9 in the denominator. And w minus 3 in this first denominator cancels with the w minus 3 in the second numerator. It's tempting to cancel those w's that are in the numerator, but they're both in the numerator. Don't do it. You can only cancel numerator to denominator, not numerator to numerator. So when we look at what's left, multiplying straight across, we have w times w, or w squared, and in the denominator we have w plus 3 times w plus 2. Now remember, that only works as long as these factors that I canceled are not equal to 0. Well, w minus 9 is not equal to 0 as long as w is not equal to 9. And w minus 3 is not equal to 0 as long as w is not equal to 3. So these are our restrictions. So the simplification only works as long as w is not equal to 9 and not equal to 3. All right, our last example on this page, we have the fraction x squared plus xy minus 12y squared all over x plus 6y times the fraction 3x plus 18y over x minus 3y. Start by factoring the numerators and denominators before we multiply. So my first numerator, x squared plus xy minus 12y squared, is a trinomial we're going to factor that into the product of two binomials, x and x, for x squared. And then negative 12y squared, try a positive 4y and a negative 3y. Double check that. Those do multiply to negative 12y, and when you multiply the outside and inside terms, they will add up to positive 1xy. My denominator, x plus 6y, has nothing common, and it's not going to factor further. So I'll just use parentheses there to kind of emphasize to myself that I know it's not going to go any further. Moving to the second fraction, 3x plus 18y has a 3 in common. When I take it out, I get x plus 6y. And then the denominator, x minus 3y, has nothing that we can take out. There's nothing common there. There's no square, so that is factored as far as we can go. So I'll use parentheses again to emphasize that I've factored it as far as I can. Now, everything is factored, so now I'm going to multiply these fractions, but first cancel common factors so I don't have as much to multiply. So x minus 3y is in the numerator and denominator, so it cancels. X plus 6y is in the numerator and denominator, so it cancels. What we're left with in the numerator is 3 times x plus 4y. In the denominator, we're left with, well, nothing, but technically it's not nothing. There's always a 1 left when you cancel, so there's a 1 left here. Remember, a numerator divided by 1 is just that whole number. So I get 3 times x plus 4y. You could distribute the 3 if you wanted, but it's not necessary. We often leave our answers in factored form. The last thing you could do is talk about what x cannot be based on these restrictions. Now, when you have two variables in the problem, generally we won't ask you to worry about this, but let's just go through it since we did it on the others. 3x minus 3y can't be equal to 0. What that means is that x cannot be equal to 3y. Likewise, if you use a similar reasoning, if x plus 6y cannot be equal to 0, then x cannot be equal to negative 6y. So if you really wanted to put your restrictions in, you'd be saying that x cannot be equal to 3y, and x cannot be equal to negative 6y. Like I said, when we have two variables in the problem, I will generally not ask you to identify what the restrictions are. I'll just mainly concentrate on it when we have just a single variable. But this is how you do it if you have multiple variables.